teacher Neth, and welcome back to our general math class. In this video lesson, we will familiarize ourselves with some properties and laws of logarithms. Given that b is greater than 0 and b is not equal to 1, and that x is a real number, the following properties are true. Since b to the first power equals b, then logarithm of b to the base b equals 1. That is, logarithm of 2 to the base 2 equals 1. And logarithm of 13 to the base 13 equals 1. Since b to the 0 equals 1, then logarithm of 1 to the base b equals 0. That is, logarithm of 1 to the base 2 equals 0, and logarithm of 1 to the base 23 equals 0. And since logarithm of x to the base b equals logarithm of x to the base b, then b raised to the logarithm of x to the base b equals x. That is, 3 raised to the logarithm of 14 to the base 3 equals 14, and 7 raised to the logarithm of 100 to the base 7 equals 100. Since b to the x equals itself, then logarithm of b to the x to the base b equals x. That is, logarithm of 9 squared to the base 9 equals 2, and logarithm of 3 to the 5th to the base 3 equals 5. For laws of logarithms, first is the product law, which states that logarithm of m times n to the base b equals logarithm of m to the base b plus logarithm of n to the base b. That is, logarithm of 2 times 5k to the base 3 equals logarithm of 2 to the base 3 plus logarithm of 5k to the base 2. Second is quotient law, which states that logarithm of m over n to the base b equals logarithm of m to the base b minus logarithm of n to the base b. That is, logarithm of h over 5 to the base 5 equals logarithm of h to the base 5 minus logarithm of 5 to the base 5. Third is power law, which states that logarithm of m to the n to the base b equals n times logarithm of m to the base b. That is, logarithm of r squared to the base 7 equals 2 times logarithm of r to the base 7.
Example 1. Evaluate each of the following. Letter A, logarithm of 1 to the base 3. We have learned from the discussion that whenever we have a logarithm of a number, and that number is 1, sometimes this is called, they call this as argument. In some other books, in some references, they call this as anti-logarithm. So whenever this number is 1, whatever the base is, the answer to the logarithm or the value of the logarithm is 0. If we would like to check that, we translate this into its exponential form or equivalent. That is, 3 to the 0 is equal to 1. Next, letter B, logarithm of 4 to the 15th power to the base 4. We have learned that whenever the argument and the base are equal, then the value of the logarithm is the exponent, 15. Because in exponential form, this is 4 to the 15th equals 4 to the 15th. Next, letter C, logarithm of 8 to the base 8. So just like what we did in letter B, whenever this number is the same as the base, then the answer is the exponent. Since the exponent here is 1, then the value of this logarithm of 8 to the base 8 is for sure 1. Next, letter D. 9 raised to the logarithm of 7 to the base 9. So this whole is an exponent, and this is the base. We have learned from the discussion from the fourth property that it is equal to 7. Whenever the base of the logarithm, which is an exponent, is the same as the base of the expression, then the answer to this whole expression is the argument or the anti-logarithm. So 7. 9 raised to the logarithm of 7 to the base 9 is equal to 7. Example 2. Expand each of the following. So in this example, since we are asked to expand, then we will be using the laws of logarithms which we have learned. The product law, quotient law, and the power law. In letter A, we have logarithm of 5x to the fourth y to the base 3. Since what is involved here is product, or we have here factors, then we will be using the product law. According to the product law, we will distribute the logarithm and the base as well to each of the factors, and they will be separated by a plus sign, meaning each logarithm will be an addend. So we are expecting here 3 addends because there are 3 factors, 5, x to the fourth, and y. So this will become logarithm of the first factor, that is 5, to the base 3, do not forget the base, plus the second logarithm will be x to the fourth because that is the second factor. Logarithm of x to the fourth, again to the base 3, plus the last is for y. So logarithm of y to the base 3. Notice that each logarithm has a base 3, so the bases must be the same. Now, since we have here x to the fourth, an expression with an exponent, still we can simplify that or expand, not simplify, by using the power law. According to the power law, the exponent will become another factor. So this whole logarithm or expansion will become logarithm of 5 to the base 3 plus, again, the exponent by power law will become a factor. So 4 times the logarithm of, that is x now, to the base 3. Its exponent becomes a factor. Plus logarithm of y to the base 3. So this is the expanded form of letter A. Next, for letter B, we have logarithm of 2a cubed over b squared to the base 4. Since what is involved here is quotient, then we will be using the quotient law. But also we have here product, so we'll also be using the product law aside from the quotient law. So this will now become, the base is always 4. So this will become logarithm of the first factor, 2 to the base 4. What will be next? We have another factor, so we'll apply first the product law. Plus, that's the product law, logarithm of a cubed. A cubed, still to the base 4. Next, we'll apply the quotient law. So this will be minus logarithm of b squared. B squared is still to the base 4. Again, we may still expand this part and this logarithm by applying to each the power law. Each exponent will become a factor. So this will now become logarithm of 2 to the base 4 plus 3 will become a factor, 3 times logarithm of a to the base 4 minus, next, again by the power law, this will be 2 times logarithm of b b to the base 4. So this is the expanded form of letter b. Oops.
In the next video lessons, we will be using more of these properties and logical methods in solving logarithmic equations and inequalities. Until next time.